All right. So we are ready to start with looking at our next chapter. This does happen to be chapter 4 in your book. It deals with ecosystems and communities. So last chapter we had dealt with energy flow through ecosystems. We're going to look more at ecosystems and those factors that shape ecosystems. So the first part of the lecture, we want to look at the role of climate in an ecosystem. Now, we had discussed last chapter something called primary productivity. That is, it took a look at the total amount of energy that an ecosystem can produce. And so climate absolutely influences this. A great example is a desert. It has a limiting nutrient, i.e. water, and because of lack of water, you have a lack of a large quantity of biomass being produced. That is, there's just not as many plants. So because you do not have as many plants, the bottom of your pyramid is smaller and smaller. If you had more plants, you can make your total pyramid, your energy pyramid, much, much larger. So climate can then directly influence your productivity, determine what limiting nutrients you have, and then that influences what kind of ecosystems you're going to end up with. So you really can't discuss the idea of an ecosystem without discussing things like climate, that is like temperature, weather, precipitation, things like that. So we need to have a basic understanding of climate in order to discuss why things live where they live. Why do we have the ecosystems that we have? So climate is not exactly weather. Weather is the condition of the atmosphere right now. And we know that in 10 minutes, the condition of the atmosphere could really change. Climate is the average year-to-year temperature and precipitation in an area. So, for example, if I ask, what's the weather going to be like in August, you could tell me it's going to be hot. There might be a few thunderstorms. In between that, it'd probably be pretty dry. That's kind of typical late July, August weather for us. Yeah, that's the climate. We don't know exactly what it's going to be each day of August, but we have a general idea about what it's going to be like. That's climate. To help us have our climate, we have something called the greenhouse effect. Now, you've heard about the greenhouse effect. Is this good or bad? Well, ultimately, it is good. Without the greenhouse effect, we would not be as warm as we currently are on the Earth. So some of you may have walked in a greenhouse before. There's a layer of plastic. It traps heat in an area. The sun shines through the plastic, and then it is trapped. And that then insulates the plants inside of that greenhouse. Carbon dioxide acts as a greenhouse gas. Water vapor helps to trap heat in our atmosphere. So does methane. All of those help to regulate our temperature so we don't fluctuate greatly in our temperatures like you would expect if your plants were not in your greenhouse. If they were just sitting outside, they could be warm or cool pretty rapidly. Trapping heat around us acts like an insulative blanket, keeps us warmer than we otherwise would be. So some really great examples of this where there's too much or too little greenhouse effect is Mercury and Venus. So Mercury is the planet closest to the sun. The side of Mercury that is facing the sun is really hot. However, the side of Mercury facing away from the sun is very, very cold. There is no gases due to its proximity to the sun. There are not gases that will trap heat and hold them in an insulated blanket around Mercury. So if you're on the dark side of Mercury, or it's night on Mercury, you're going to get very, very cold, like space cold. On the other hand, Venus, which is actually further away from the sun, has a super dense, thick atmosphere, whereas Mercury virtually doesn't have an atmosphere. Mercury's atmosphere is so thick that it traps so much heat and holds it in so effectively that you're melting lead just at normal day temperatures on Venus. And even when the sun goes down on Venus, it's still hot because that doesn't have a chance to lose that heat to space. So we don't want to have a Mercury greenhouse effect that would make us much cooler than we are. And we don't want to have a Venus greenhouse effect because then that would keep us, if we did, we'd be way too hot. And that would also be problematic. So we've got a good greenhouse effect going on, and that is not a bad thing. We like things how they are. So we can see in this diagram how those greenhouse gases help to trap your heat and in the form of radiation and hold it in like a cushion around the Earth. Therefore, we don't necessarily get all that solar energy trapped around us, but we get enough to keep ourselves at a certain nice temperature, and it stabilizes the Earth's total amount of energy we have around us. So that's a good thing. With that said, there are different places in the Earth that are different temperature. So this is influenced by the tilt of the Earth in relation to the sun. So you might remember that the Earth is tilted 23.5 degrees in relation to the sun. That axial tilt is responsible for the angle at which sunlight hits the Earth, and the angle with which sunlight hits the Earth influences how much total energy we get. Thus, depending on where you are on the Earth, you can have different climate zones. So here's a good example of that. So from the equator to approximately 30 degrees north and south, which really this would be better if it was 23.5 degrees north and south, giving us the Tropic of Cancer and the Tropic of Capricorn. Those are the areas by which you get the most direct solar radiation, all through this tropical zone through here. In your temperate zones, you get less direct or seasonally less direct solar radiation. So in our summertime, the northern hemisphere is tilted towards the sun, and therefore you're hitting this surface of the curved sphere of the Earth more directly. Thus, we get a greater influx of solar radiation. So we get to have summertime. And conversely, in the southern hemisphere, they're having winter. So right now, or we just came out of winter, and so we were tilted away from the sun, which meant the sun was hitting at a lower angle. So we did not get as much direct sunlight, and we did not get as much solar energy. So we're warming back up now, and it's getting us back into summertime. All right. And so you can see these different zones really. So through the center of the Earth, the tropics, which we even use that name, is the tropical zone. And we have temperate zones. And at the top and bottom of our planet, the Arctic and the Antarctic, we have polar zones. Now, why do the polar zones always have ice and snow? Well, because sun is never going to hit directly onto that pole. It's always going to be hitting at an angle, a very low angle, thus spreading out the amount of solar radiation that you're going to get. So it's always going to be cold there. Now, if we would trap more heat around the Earth, we could heat up those polar zones. However, that trapped heat would also make those tropical zones even hotter and make it more unbearable for life. Okay. Temperature is just one component, however, of climate. The other one is the amount of precipitation that you're going to get. And that is influenced by climate, or by heat. Heat gets moved around in the biosphere, in our atmosphere, in multiple ways, through large global winds and through large global ocean currents. Both of these are types of convection currents, and you might remember talking about these types of currents. We all know that hot air rises and conversely cold air sinks. So if we're heating up air here along the tropical zone, it's going to rise. If we're cooling down air, it's going to sink. That creates large global wind patterns for us in these giant, convection currents, and then that determines our prevailing wind. Okay, which direction is our wind typically move from, or our weather comes in from? Usually here it's moving in from the north or northwest. That's due to those prevailing wind currents. If we were in a different part of the world, that might come from a different direction. Ocean currents also are driven by hot air rises, so does hot water rises and cold water sinks. That then creates convection currents in the ocean, which also serves to move around heat. So here in this diagram, you can see kind of a cross-section of the wind patterns that we'd have. As we have heat rising around the equator, we go up, and then that will sink at those subtropical areas, and it will fall, and that will create these wind patterns. Now, keep in mind the Earth is also spinning at the same time, so those wind patterns are not directly towards or away the equator. Our prevailing winds are the westerlies, and that's why most of our weather comes from the west. Here are some examples of some different ocean currents. The red represents warmer water, the blue represents cooler water. And so this cycles warm water from the equator and moves it different directions and moves cooler water from the north and south poles, maybe towards the equator. So what impact does this have on us? Well, for one, if you've ever been to the ocean, depending on if you've been to the Atlantic Ocean, like maybe on the East Coast, or the Pacific Ocean on the West Coast, you've noticed that the ocean on the West Coast is actually cooler than the ocean on the East Coast. You would think it'd be warmer because of where you're at, but you've got this California current coming down from the Bering Sea that's actually bringing cooler air along with it. That influences the climate along the west coast of the United States. That's why areas like San Francisco have such a nice, cool climate all year round. It's very stabilized by that energy that's being soaked up by that cool current. It helps it's kind of like an air conditioner. Conversely, we get some warmer water coming up the coast of the eastern United States. This is very interesting. So right about here, we're in the central part of Canada, right? So if we kind of imagine the weather in the central part of Canada, your winters are going to be really, really cold. There's going to be lots of snow. It's going to be pretty chilly. However, if I ask you to imagine what winter is going to be like in England, you typically don't think of super cold conditions. Yet if I draw a line directly across here, England is at the same latitude as central Canada. How come England does not have super duper cold, snowy winters? It's rainy there, but it's not cold. Well, that's because this Gulf Stream moves up and carries warm water currents past the British Isles here and keeps England warmer than it otherwise would be. So that's a pretty good example of these currents moving air or heat around that then influences air temperature, which influences our climate and subsequently our day-to-day weather. All right, we'll pick up with some different other aspects of this next time.